All right, today we're going to talk about key topic 20, power sources. And that's the power sources set up for your radio telephone installation. Might be an opportunity to talk about part 80 a little further. Part 80 is where most of our requirements come from, and it consists of several subparts. I think today we're mostly going to look at the power sources, so let's see where that might be. The various parts, the various subparts actually have their own individual requirements. So if I'm noticing there's some general requirements for the first subparts, and then as we go down a little further, there's the various coast stations. J is public coast stations, K is private coast stations. Let me go ahead and click on those just so you can kind of see what I mean. And there's a number of, let's call it, sub-regulations under each of those. So public coast stations, which we're not going to be that concerned about. There's not that many questions that we haven't already covered. Private coast stations, operational fixed stations, and I believe there's going to be a few other support type stations. Alaska fixed stations, and subpart P ends. I got stuck there because Q is reserved. Yeah, Q is reserved. For some reason it stops me, which is kind of a good cutoff point because mostly of what we're looking at are the higher subparts, like the one on the screen, the radio telephone installations. And you can already see by scrolling down that there's a main power supply and a reserve power supply. So, and we've already gone through these basically section by section, so you might remember that. This is kind of split into two sections. There's an applicability at 851 and also an applicability a little further down. If we take a quick look at those, the top part, it says it's all the ones that are compulsory ships, but they're not required to comply with subpart W, which is this whole section that we're looking at, mostly because they've received an exemption. And the other lower applicability at 1065 is basically the main applicability of the GMDSS system. It basically applies to all passenger ships, regardless of size. So there's no 10 passenger or more requirement, and all cargo ships of 300 gross tonnage and upwards, which we did see those requirements in order to come under the convention. There are some exceptions because they have their own requirements. The Great Lakes is one of them, and as an overall, they do say in C that nothing in this subpart is intended to prevent any ship or survival craft or any person in distress to use any means at their disposal to attract attention. So it's not like I can't do something because it's against the regulations. You can go ahead, if you're in distress, use any means at your disposal. But as we look down there at the GMDSS, we can see the first part is talking about what frequencies and records, exemptions perhaps. Then this sub part is equipment required for ship stations, which we're mostly interested in because our aircraft are similar to a ship station. So the more we know about ship stations, aircraft stations are going to be elementary. So we're going to take a look at these mostly right here. The subsections of Part 80, subsections 1081 through, let's say, the 1099, which is the ship sources of energy. And that's basically our topic for today, the sources of energy. But just so we could put it into context, and basically these are the regulations that a radio technician would have to adhere to. So it's good for you to know what the regulations are. So it is kind of handy that that a lawyer is presenting these for you. But let's go ahead and click and quickly scroll through these. The first one, functional requirements. Basically, they have to have, if you're going to have distress alerts, you have to have two separate and independent means, each using a different radio communication service. And you can see a number of items that they want under that requirement. Receiving distress alerts, a lot of this is distress, search and rescue, on-scene communications, locating, maritime safety. Next, ship radio installations. Ships must be, have certain radio installations installed. Basically, I think we may have looked at this. We certainly see that you have to protect against the harmful effect of water, extreme temperature, and other things like vibration. C, basically you have to be close to the navigating bridge or in a connecting room. All right, so basically nothing that's going to apply to us today. Next one. In general, the ship's radio equipment, this is the general requirement. Ships must have a VHF radio installation capable of transmitting and receiving the DSC signal on the frequency we looked at before, channel 70, which is 156.525 megahertz. And basically that is the general requirement. There's going to be a few other items down there if you're involved in any other type of voyage. But at this point, let's just leave it at that. VHF for DSC. Then they get a little more specific as you get into the C areas. C area A1, you may remember, is being fairly close to shore. That is within range of the VHF radio signals. So in addition to what we just looked at, the general requirements, ships that voyage exclusively in the C area 1 must have the VHF using DSC. And then there's a lot of ORs. Or if you're in a polar orbit, you have to get into the EPIRBs, or medium frequencies, DSC, if you're going to be a little further, or high frequency, or in Marsat. So there's a lot of ORs. But in C Area 1, the only one that you really need would be the first one. Now, if you have the other ones, since they're all ORs, you're going to be in compliance. But that is in addition to the general requirement, which is the VHF DSC. So next, you're out a little further. You're in C area A1 and A2. So let's see if they give us, basically in addition to the prior, which is the VHF, you must also have the medium frequency. Now you might be out 20 to 100 miles from shore, and VHF may only have a range of 40 miles. So what if you're 60 miles out? You're not going to, your VHF radio is not going to be capable of sending a distress signal to shore, in effect. So in addition to that requirements, you have to have the medium frequency, which we saw that does bounce off the ionosphere, and it can go for 100, 150 miles, up to maybe 400 miles at night. And so basically you have to have some sort of medium frequency radio installation, which uses that 2187.5 kilohertz emergency medium frequency channel that uses the DSC. If you're going to use it by voice or telephone, it's 2182. So if you're going to go further out, you need the medium frequency, and then you're going to see a lot of ors after that. So you go a little further out. You're in A1, A2, and A3. So in addition to the above, you also need something that moves into the satellite area, because you're beyond 120 miles from shore. So even perhaps the medium frequency waves aren't going to reach you, or you're in that skip zone where medium frequency is bouncing off the ionosphere rather than going directly to your ship. So apparently you must be provided with the satellite Earth station, which can basically transmit and receive on that frequency. And you need the medium frequency, and you need to have the medium frequency DSC watch, and of course ship to shore distress alerts. And if you're in polar, you need the EPIRBs, which we're going to cover in its own section. There's only going to be 4 sections left after today. All right, do we go next? Well, this one's a little shorter compared to the others because it concludes A4, which I believe is the polar regions. And so basically it's referring to you must have everything that you had in the section before. So you need all the satellite, medium frequency, VHF. Survival craft equipment, that is one of the remaining 4 sections, so I think I'm going to save it for that. There's going to be a section on survival craft equipment, and there's also going to be another section of the 4 on this SART, search and rescue locating device. Ship sources of energy, 1099. It's like a W-2 form that you get, but it's a 1099. They didn't withhold taxes on you. So this is basically what this section is going to be testing us on, the ship sources of energy. And you would think that they're talking about the actual primary source of energy, but if you actually look at the regulation, most of it is talking about the reserve source of energy. So yeah, while the ship is at sea, there must be a supply of electrical energy sufficient to operate the equipment, charge the batteries, and so on and so forth. But there is requirements for the reserve source of energy. All right, so the reserve source of energy must be capable of simultaneously operating the VHF radio equipment, depending on the sea areas in which you're operating. Either the medium frequency, that's required under the further out requirements, the medium or high frequency, and there's the or right there. So it's going to be one of these ors. So the reserve must be at least capable of operating your VHF equipment. There's the various, how long can usually the reserve source of energy are batteries that are placed very close to the radio equipment. If it's basically a newer ship, for some reason the requirement is only 1 hour that the batteries have to operate continuously. But the older ships, constructed before 1995, do have a 6-hour requirement. And there's some exceptions if you read it closely, but the general rule is the older ships, which most of the ships out there are before 1995, they do require 6 hours of, let's say, battery power. The reserve sources of energy need not supply independent high frequency and medium frequency radio installations at the same time. So there's no requirement. There's definitely VHF, but as far as high frequency and medium frequency, there is no requirement that the reserve sources have to do either both at the same time. I don't think D is going to apply to us that much. E, the reserve sources of energy may be used to supply the electrical lighting required. F, where the reserve source of energy consists of a rechargeable battery, you must be able to charge the batteries within 10 hours. You should check your battery levels at intervals of 30 days or less. The accumulator batteries that provide the source of energy must be installed to ensure the highest degree of service, etc., etc. Operation under all weather conditions. Basically, they came up with these because there was ships that, because of the strong weather in the Baltic Sea, which is way up by Canada and Russia, it's almost considered part of the Arctic Ocean. There's a reality show, The Deadliest Catch, that takes place on the Baltic Sea. So the heavy waves knocked over the little control house on the top of the ship, and the only thing they had left to communicate with the Coast Guard was the EPIRBs. So basically, as part of the safety of life at sea, they've come up with this emergency source of power that can power your radio, especially if you're losing the primary power source. All right, I believe that's going to be it. There's going to be some performance standards. I'm not going to be that concerned about that. Let me pop back to part 80. How far did that take us? Okay, ship sources of energy. We went to 1099. And that's the equipment requirements for ship stations. The other requirements do talk about the distress and safety communications, which we had already looked at fairly extensively. All right, I think that might be enough background information to jump into our presentation. If I can minimize this screen. There we go. All right, power sources. Which of the following terms is defined as a backup power source that provides power to radio installations for the purpose of conducting distress and safety communications when the vessel's main and emergency generators cannot? So the backup power source. What type of term defines it? Okay, let me launch the poll. So what do they call that? Is that called the emergency diesel generator? Or B, reserve source of energy? Or C, reserve source of diesel power? Or D, emergency backup generator? Yeah, basically that section we looked at, 1099, definitely referred to reserve source of energy a few different times. Okay, next question. In the event of failure of the main and emergency sources of electrical power, what is the term for the source required to supply the GMDSS Council with power for conducting distress and other radio communications? You can see the question is very similar. It's just got a lot of extra words in it. But if you search for the main words, you're going to see there's a failure of the main and emergency sources of electrical power, and then what type of source is going to be required. Is that A, emergency power, B, ship's emergency diesel generator? I think it's almost the same options. C, reserve source of energy, or D, ship's standby generator? Yeah, and of those, it looks like a reserve source of energy would be the best answer. So they do like that word. Let me end the poll, share the results. All right, so apparently the RSE, the reserve source of energy, looks good on this voltmeter reading. Yeah, and you can kind of see the darkened end. It's not the best picture. This is an older demonstration. It even looks like there's corrosion on what appears to be hinges. Share results. More with this reserve source of energy. What is the meaning of reserve source of energy? A, the supply of electrical energy is sufficient to operate the radio installations for the purpose of conducting distress and safety communications in the event of failure of the ship's main and emergency sources of electrical power. A lot of words, but none of them sounded bad. B, high caloric value items for lifeboats per SOLAS regulations. So what, you have to have some energy bars or granola bars on the lifeboat so that you can keep up the individual victims' energy? C, diesel fuel stored for the purpose of operating the powered survival craft for a period equaling to or exceeding the U.S. Coast Guard or the safety of life at sea requirements. So do you have to have in your survival craft a few extra gas cans, so in case you run out of fuel? Or D, none of these? 800 number. Basically, it's not granola bars, and it's not extra gas fuel tanks. And there's certainly the meaning of reserve source of energy certainly looks like it's going to be A. That is what they refer to it, and that looks like an actual definition. All right, so there's 3 questions, and basically they're all the reserve source of energy. What are the characteristics of the reserve source of energy under GMDSS? Okay, maybe there's 4 questions that have to do with this. You notice how none of them are asking about the primary energy source? They're mostly concerned about the requirements of the reserve energy source. So the characteristics of the RSE, is it A, supplies independent HF and MF installations at the same time? Well, actually, we saw that that was something that specifically said it does not have to do. B, it cannot be independent of the propelling power of the ship. I might have skipped over that subsection, but I think it was C, yes. The reserve sources of energy need not supply independent HF and MF radio installations at the same time, so A is wrong. And look at the second sentence. The reserve sources of energy must be independent of the propelling power of the ship and the ship's electrical system. So C is basically going to answer this question for us. All right, so we know that it's not A. It cannot be independent of the propelling power of the ship. Well, we just saw that it must be independent of the propelling power of the ship. Or D, must be incorporated in the ship's electrical system. No, we also saw that it must not be included in the ship's electrical system. So C is going to be it. It must be independent of the ship's electrical system, where the reserve source of energy is needed when it is needed to supply power to the emergency equipment or the radio equipment. All right, so 4 are very similar. How about, can we go one more? And well, let me end the poll, share the results. All right, what is the requirement for emergency and reserve power in GMDSS radio installations? Very similar. A, an emergency power source for radio communications is not required if a vessel has a proper reserve power. So if you have good batteries, do you not need an emergency power source? That doesn't sound like that would be right. B, a reserve power source is not required for radio communications, period. Well, we pretty much know that that's not true. C, only one of the above is required if a vessel is equipped with a second 406 EPIRB as a backup means of sending a distress alert. A little bit confusing there, but let's go ahead and see what D says. All newly constructed ships under GMDSS must have both emergency and reserve power sources for radio communications. You know, I don't know if we saw an exact regulation that says that, but I'm sure there is. So any new ship construction, you're not only you're gonna have both. You're gonna have your emergency source and a reserve power source. So I'm going with D also. Yes. The reserve power supply must simultaneously energize the reserve transmitter and its required antenna power and the reserve receiver for at least 1 hour continuously. Okay. End poll. Share the results. All right, I was looking for something in part 80, and it is in the second part of subpart, well, it says R, but it's actually subpart W. And let's look at the applicability of it. The GMDSS does apply to all passenger ships. We did look at that, and cargo ships of over 300 gross tons. Well, the next section did have the inspection of the station. I just pretty much flew by it, but I'm going to slow us down a little bit. Ships must have the required equipment inspected at least every 12 months by an FCC licensed technician holding a GMDSS radio maintainer's license. So, you know, that's something that, you know, you guys are getting pretty close to being qualified to do. That's, of course, if we count this as element 1 and then we end up getting our radio operator license, which is the element 3. There's also elements, I think it's 4 and 5, which have to do with GMDSS. And the higher one is someone that actually inspects the radio equipment. And you see all the ships that are coming into the Port Everglades here. So you know that a lot of them are going to have an inspection of their radio equipment. So there are going to be local companies that do that, and certainly they're looking for technicians. So a little bit like ships are very similar. I mean, if you're actually working on the radio and the navigation and the other, what we would call avionics, the electronic equipment on ships, you're basically positioned, probably if it's yachts, you're going to be at a what are they called in the harbor where you actually have a marina. So you're going to be working at a marina, or you're going to be working at shipyard somewhere, and basically your vessels are going to be leaving on the water, and they're going to want to know. There's going to be a lot of similarities to aircraft, which is why we're kind of studying this, because all the equipment was perfected for ships, and now we're applying it for aviation. And we work at the various airports, and our vessels are basically using the air instead of the sea. But other than that, when we communicate with them, we're going to be using radios, and when they want to navigate, you're going to see that there's a number of screens that pop up on your avionics equipment. So basically, there is a requirement of inspection of your equipment, and that's every 12 months. And it's not going to be by the commission themselves. It's going to be by someone that holds that element level license. So the question is, for a small passenger vessel inspection, reserve power batteries must be tested how often? Every 3 months, every 6 months, before a new voyage, or at intervals not exceeding 12 months or during the inspection. A poorly written question. I had so much trouble finding the inspection requirement for reserve power batteries because this section has been rewritten a few times. Um, some of the original subsections they refer to have been removed, and new reserve power sources have been rewritten. But we do have that general requirement that we just looked at for GMDSS. Right after applicability is the inspection of the equipment, and the one that we just looked at did say every 12 months. That type of inspection of a battery would be specific gravity tests. So basically, you're using your hydrometer in the battery to basically see what the specific gravity is, or in effect, the ratio of acid to water. The battery should be free of terminal deposits. That's pretty obviously that's something for your automobile also. You should check for deposits on your terminals. Otherwise, you're going to be going through batteries a lot quicker, or you're going to get stranded somewhere. All right. And yeah, 808 isn't even in existence anymore. So that's what kind of threw me off a little bit. And I believe that's going to wrap it up for this presentation. It sure does.